Good morning, students. Welcome to online class. On continuation of our electrical and electronics measuring instruments EE 304 C18 subject. We have already completed basic principles of moving coil instrument and moving iron instrument. In this session, we are going to explore another interesting instrument is wattmeter. Let us see in details of our electro dynamometer type instrument, that is wattmeter. Now let us introduce myself. My name is Dr. C.H. Yadaya, Senior Lecturer in Electrical and Electronics Engineering, Government Polytechnic, Hosnabad. Recap what you have seen previous classes. So last class we have seen that the basic constructions of moving coil instrument and its constructions and its working principle, applications, and how to enhance the rating of moving coil instrument as a voltmeter, as a ammeter. Similarly, we also covered moving iron instrument, its construction, types, attraction type and a repulsion type, the working principle of these 2 meters and advantages and disadvantages we have covered. In this lesson, today our object is, on completion of this period, you would be able to know the comparison between moving coil and moving iron instruments, the construction of dynamometer type instrument, the working principle of dynamometer type instrument. And dynamometer type instrument act as a voltmeter and ammeter in our electrical fields. As you know that, you can see what is this one. Have you remembered that thing? Yes, this is the first one is the moving MC instrument. This is the moving iron instrument attraction type. So we are going to compare between the two instruments in few aspects, important aspects. Okay, so you know the basic principle of this moving coil instrument. It has the 2 magnetic fields. One magnetic field is produced by permanent magnet, that is a U-shaped magnet, is a north pole and south pole, and there is a electromagnetic coil is placed on a spindle, an aluminum frame, and placed on a spindle, and it will move on a calibrated scale when supply is given to this coil. This is basic principle. Now, when in case of moving iron instruments, in this case we are using that one electromagnetic field, another is a soft iron which is magnetized under influence of this magnetic field. So here oval shaped iron piece is placed, and here is a magnetic coil, electromagnet, solenoid, and whenever the variable to be measured is given to this coil, it establishes the magnetic field and it will try to attract the soft iron towards inside of the coil. Thereby it rotates its spindle and pointer, and we are going to measure that value on a calibrated scale. Everything we have seen, how the deflecting torque is generated in both cases, how the controlling torque is produced, and how the damping torques are applied in this case, we have seen each and every one. When spring control, what is happened? So the theta angle of deflection is directly proportional to the current in case of the moving coil instrument, whereas theta is directly proportional to the square of the current in case of the moving iron instruments, whether it is the attraction type or repulsion type. So due to this one, we have observed that the scale is not uniform in this case of moving iron instruments, because theta is directly proportional to the square of the current. It is the non-linear value, whereas moving coil instruments, the theta is directly proportional to the current. Scale is uniform. So moving coil instruments has a scale uniform, but whereas a moving iron instrument is cramped at starting at ending. And spring controlled, gravity controlled, eddy current damping, air friction damping, and fluid friction damping, 3 different types of dampings were applied in both cases. Now we will compare the moving coil instrument and moving iron instrument with few aspects, important aspects. Okay, let us see. Now what is the first one is the, here you can see what is the first one. Now if you are seeing that the moving coil instrument, the deflecting torque, how we are going to produce the deflecting torque? Here deflecting torque, that means deflecting, that means we are going to get that, so we require the TD. So TD directly proportional to the input value, whether it is a current or voltage in both cases. Now this deflecting torque is produced if input supply is given to this instrument. Input supply is given to this instrument. The deflecting torque which is required to move the pointer from this place to this final position, from this place to and this position. Similarly here. So in moving coil instruments, so we are going to get in this case, coil moves in the magnetic field. This coil is moved in a magnetic field developed by the E-shaped magnet. Okay, so that is the TD is produced directly proportional to the input value, that is the current or voltage. Okay, so that is produced, the coil moves in a magnetic field, coil is moving on the magnetic coil, whereas in this case a soft iron moves in the magnetic field. This soft iron is moved in the magnetic field. Here the coil moves, so that is why this is iron, moving iron, this is a coil, that is why moving coil. MC and MI. First aspects, the deflecting torque produced in moving coil instrument is the coil moves in the magnetic field, whereas in the moving iron the soft iron moves in the magnetic field. Now second aspect, what is the deflecting torque and current relation here? So TD versus current. Here moving coil instruments, the deflecting torque is proportional to the current. Here TD directly proportional to the current. If the current is more, deflecting torque is more in case of the moving coil instruments. Whereas in this case the TD deflecting torque is directly proportional to the square of the current. TD is proportional to square of the current. That's why the scale here cramped at starting and ending. That is the second point. The deflection torque which is produced is directly proportional to the current in case of this one. Whereas in this case, the moving iron instruments, so here the deflection torque is directly proportional to the square of the current. Whether it may be voltage or current, any type of the effect. So we have seen electromagnetic effect, electrodynamic effect, electrostatic effect, heat effect, and hollow effect and chemical effect. Any type of the energy we are going to measure that is given to the as an input value that will change the deflecting torque. This deflecting torque produced in the moving coil instrument is directly proportional to that variable which we are going to measure. Whereas in case of the moving iron instruments, so that deflecting torque is directly proportional to the variable which is given to the instrument is the square of that value. That is the second aspect. Now coming to the third one, the damping torque. So we are going to use it T-damping. Okay, T-damping. How we are going? What is the damping torque? You are going to produce in moving coil instruments and moving iron instruments. In this case, moving coil instruments, generally the damping is produced by the eddy current damping. Eddy current damping. As you observed here, the iron core, there is a iron core on which there is a aluminum frame on which this coil is wound. This one. So here aluminum frame act as a eddy currenting damping. Okay, so eddy current damping is provided in the moving coil instrument. And whereas in this case, so here you can see it, the air friction damping is provided. Generally, so we opt for air friction damping. There is a cylinder and piston air friction damping. How it works already we have seen. That is the third aspects we are going to consider. So damping torque is produced in the moving coil instrument in the eddy current damping torque in case of the moving coil instruments, and air friction damping generally employed in moving iron instruments. And another aspect is the controlling torque TC. So what is the TC? The TC is a controlling torque. So the controlling torque produced with the help of the spring controls and gravity controls. So which type of the control torque used in both cases? Now in moving coil instruments we are using the spring control. We are using the spring. You can see the spring top and bottom. Spring control we are used in this case. Whereas in this case we are going to use a gravity control. You can see the weight is added to the in this case spindle. Some weights are here. So here is a gravity control and here is the spring. Phosphorus branch hair spring are generally used and both side of the coil. Whereas the gravity control, so we used in case of the moving iron instruments. There is a fourth aspect. Now the fifth aspect and is the controlling torque. And here what is the controlling torque? Here the controlling torque is proportional to the deflection. So TC controlling torque, TC directly proportional to you can write it TC. TC is proportional to the angle of the theta deflection, angle of the theta in case of moving iron instruments. That is, controlling torque is proportional to the angle of the deflection. How much is the deflected angle from initial to this one? What is the theta? The controlling torque is proportional to angle of the deflection in case of moving coil instruments. Whereas in this case, the controlling torque due to the gravity is directly proportional to sin theta. Okay, in this case sin theta, in this case only theta. So, sin angle of the deflection in this case due to the gravity control method. So, we are going to get the controlling torque is directly proportional to sin theta, whereas in this case, so due to the spring control we are going to get this. So, directly controlling torque is directly from the theta angle of deflection. This is one aspect. Due to this one, what will happen? The scale. So, that is another aspect. Scale. What is the scale here? The scale whether it is a uniform or cramped. So, in this case, because the T deflecting torque as well as the controlling torque is directly proportional to the theta. So, the scale is uniform. So, that is the same uniform length scale. Whereas, here the torque, controlling torque is directly proportional to square of the time. That is the dt is proportional to the square of the current non-linear, and Tc also directly proportional to the sin theta. So, scale is not uniform, it is a linear. So, it is a scale is manufactured such a that initially the distance between the digit to digit is less, and when in middle the digit to digit length is increases, and once again ending also is less. That means here and here its scale is cramped, zigzagged, the very small distance between the point to point. Whereas same value of this one, their distance is more. The arc length is changes, you can observe, already we have seen. So, scale is not uniform in case of the moving iron instruments, and scale is uniform in the moving coil instruments. This is the one aspect. Now, another is the construction. So, what is the construction here? Construction point of view. So, construction point of view, which is the delicate, which is the strong, which is the robust, and so which is we are going to see. So, here the construction point of view, if you are seeing the moving coil instrument is a very delicate, because due to the coil itself, very delicate instruments. So, while using the moving coil instruments, we should take care. At the same time, it is a very sensitive, delicate and sensitive. So, that is the things. Now, whereas in this case, it is a robust, you can see, and it will also give the accurate value. Dear students, please remember, I am going to assuming that the moving coil instrument here, the moving coil instrument as a one girl. Okay, moving coil instrument is a just you assume it one girl student. Now, this is a daughter, nothing but daughter. Now, this moving iron instrument I am assumed as a my son. So, what has happened here? So, my God, always girls are very delicate, sensitive, and whereas the son is always robust, and this fellow cannot hear me, she can hear most of the time, and so I can send this kid only for taking the medicines from the medical shop in emergency case during the daytime only. That means I can use these instruments for only DC. This person, my son, if in case of emergency, he can go to the medical shop in daytime or at night at 11 o'clock also. That means I can use this my person for in case of the emergency at daytime and night time. That means I can use this type of the MI instruments for AC as well as DC, just like you remember. Whereas moving coil instrument is a I can use only daytime because I cannot send my daughter at night to the medical shop even in emergency. That's why, so because she is a delicate and she is a sensitive. That's why I can use only for DC, whereas my son is able to withstand alternating current. So he is robust. That's why, so don't use the moving coil instruments for measurement of AC measurement. If you want to use it, you want to use both, you can use my son, that is a moving iron instrument, because he is a robust and reasonably accurate value he will give. But whereas this moving DC, it will give the accurate value, but it's a physically it is a sensitive and delicate. Okay. Now then another aspect is power consumption. So what is the power? How much power will take? Because already I have said she is my daughter. She is my daughter. He is my son. So as you know that my daughter will consume less food, where this fellow is going to the gym, he will consume more food. Similarly, the moving coil instrument consume less power, whereas here moving iron instruments, because less power. Why? Because here to produce the magnetic field only in electromagnetic coil only. Already there is a existed U-shaped magnetic field. Only single magnetic field is required here. But whereas in this moving iron instruments, so here require two magnetic field. One is a magnetized, this one, another this iron piece. At the same time, it also becomes a magnet. The coil, whenever the current passes into the magnet, the coil, the armature of the moving iron, it has to become the magnet, and this magnetic field will try to magnetize the nearby iron piece. So whatever the magnetized property gained by this iron piece becomes as a one magnet. So this magnet depend upon this current, input current, and this coil armature current also depend upon the magnetic field also depend upon the current. So that's why, so that is a deflecting torque is directly plus square of the current. So here, so it requires the more magnetic field is required to magnetize a nearby iron piece. So hence it will take the more current, hence the power consumption in moving coil instrument is very low as compared to the moving iron instrument. Okay. Now next factor is the application. So application of oriented. So that is means, so applications. So what is the application? Just like I explained. Suppose in case of emergency, I require the headache tablets or cough tablets. So I am unable to go out, then I can send my daughter during the daytime to the medical shop to bring the tablet. But in case of the night, I cannot send my daughter, I can send only my son to bring the emergency tablets even at 12 o'clock. That's why, so application point of view, this is a very sensitive and delicate, so that can be used for only for DC. Whereas this is my robust son, so daily is going to the sports club, he going to the gym, so is a robust and it can withstand any type of the resistance. So I can use AC as well as DC, both current I can use this instrument. So you can remember one, students, suppose I want to measure the DC current. If I used my daughter to measure the DC, she will give the value of, for example, 0.123 amperes. Instead of my daughter, if I used my son, MI to measure the same load current in case of DC. Then he will give the value only 0.13 directly he will give. So nearly accurate, but whereas in DC, so it will give the more accurate value. Whereas in MI instruments, it will give the nearby accurate value. Okay. Now another is the only meters. The meter can be used as this meter, MC meter can be used as one is we can use the voltmeter. I can convert this meter into voltmeter, and ammeter and galvanometer. Okay, galvanometer. Whereas this moving eye instrument, I can convert it into ammeter, voltmeter. If possible, I can convert into wattmeter also. Same moving coil instrument can be used as ammeter and voltmeter. Already we have seen in previous classes. Once the moving coil instruments, if you are using it as a ammeter, no need to connect the extra resistance in series to this one. Suppose I want to connect the same moving coil instrument as ammeter, as a voltmeter, I have to connect the one extra resistance in series, because already we know that the all current coil always less resistance. So that's always connected with the help of the some support in series to the load. But while you are using it as a voltmeter, so it is connected across the supply, across the load. So and at that condition, so you require connect the one extra resistance in series to the coil. Okay, so these are basic things. Now these are the some 10 aspects. What are the aspects we have seen? So once again I will repeat this one. So first one is the deflecting torque, that is the TD. The deflecting torque, so here the coil moves in the magnetic field, and moving iron, the soft iron moves in the magnetic field. The movement of the deflect, which is the deflect? Here the coil is deflecting, here is the iron piece is deflecting. With the coil or iron piece deflected, so ultimately the pointer will rotate on a calibrated scale. That is a deflecting torque produced. And the deflecting torque is directly deflecting torque current relation. What is the relation? In this case, the deflecting torque produced proportional to the current. So directly proportional to the current in this case, but in this case I scale directly proportional to square of the current. And damping torque, so in this case damping torque, T damp, so T damping is produced by the eddy current damping, so aluminum frame. Whereas in this case we have provided the air friction damping, we can see here directly. Next, TC controlling torque, the controlling torque produced by the springs provided here and here. In this case controlling torque is produced by some weights, that is the gravity control. And controlling torque, relation between the controlling torque and deflection. So in this control torque directly proportional to the theta, whereas the TC is directly proportional to the square of theta square of the angle, or we can say, so controlling torque is directly proportional to the sine theta. We can say this is a sine theta. Here simple theta, this sine theta. So that's why scale is a uniform here, scale is not uniform, cramped at starting and ending. And due to this one, the construction is a very delicate and sensitive. Hence, I can use only for a DC purpose. Whereas this construction point of view, it is a very robust and reasonably it will give the accurate value. So that's why I can use as a AC as well as DC measurement purpose. These are the 10 aspects you should remember, because you are the electrical students. You are going to use anywhere this voltmeter, ammeters, all are based on these principles only. So you have to identify. So physical point of view is same, but you have to identify. Last class we have seen it has a plus, it has a minus in case of the moving coil instruments, and there is no plus minus in case of the moving iron instruments. If you are seeing the inside, there is a U-shaped magnet inside the moving coil instruments, whereas the moving iron instruments there is a one zigzag coil and rod, iron piece. Or sometimes the scale is uniform, scale is not uniform. These are the differences you have to remember lifelong to identify, to use the perfect meters for the measuring your applications. Okay, so this is a simple comparison between the moving coil and moving iron instruments. So we already covered in previous classes. Now once again this one. This is an important question for you also. Okay, so dear students, now let us enter into our topic. I think okay, so they will stop here and we will see the directly that one. So because dynamometer type wattmeter is a separate topic, but previous classes we covered moving iron and moving coil is a small topic. You can see the small topic. So now we will end this one. We will start next topic in the next episode.